Hey everyone, ready for a deep dive into something truly revolutionary?
I'm ready. Let's do it.
Awesome. Today we're taking a close look at the Attention is All You Need paper, which introduced the transformer.
Yeah, this paper from a team at Google back in 2017 really shook up the machine learning world.
Right? Especially for things like language translation and other sequence transduction tasks.
Yeah, and the results they got were truly remarkable. Like on the WMT 2014 English to German translation
Oh
test,
yeah, that was impressive.
they achieved a BLEU score of 28.4,
Wow.
which at the time was a new state of the art. It even beat out all those more complex ensemble models that were around.
Okay, hold on. I think we need to back up a bit for those who might not be as familiar with this.
Oh, sure.
What exactly is a BLEU score?
Right. And why is it such a big deal here?
Exactly.
Well, BLEU stands for Bilingual Evaluation Understudy. It's a way to measure how good a machine-generated translation is
Okay,
by comparing it to human translations. Basically, the closer the machine translation is to what a human would do.
I see. The higher the BLEU score, so it ranges from 0 to 100.
So hitting a BLEU score of 28.4 means that the Transformers translations were, like, way more fluent and closer to human level than anything else we'd seen before.
Yeah. That's exactly right. And this is particularly impressive because of how the transformer actually works, you know?
Right.
It processes information this totally different way.
Exactly. And it's all about attention.
It is all about attention.
But before we dive into that, can you quickly remind us how those traditional RNNs, the recurrent neural networks, how did they work?
Sure. So RNNs, they kind of process data step by step,
Okay.
kind of like reading a sentence word by word. But they weren't very good at understanding the connections between words that were far apart,
Yeah.
especially in longer sequences.
Yeah, they really struggle with longer
Yeah.
sequences. I remember that.
Right.
Okay, so how does the transformer tackle this problem? What's the secret sauce?
Well, as you said, it's all about attention. Instead of going through a sequence like word by word.
The transformer uses a mechanism called, get this, scaled dot product attention.
Scaled dot product attention.
Mm-hmm. It's like shining a spotlight on the most important parts of the input, no matter where they are in the sequence.
That's cool.
So it's all about relationships between different parts of the sequence and understanding those all at once.
That's wild. Okay, but break this scaled dot product attention down for me a little bit.
Sure.
How does it actually work? It sounds pretty complicated.
It is a bit on the technical side, but essentially it involves calculations using queries, keys, and values from the input sequence.
Queries, keys, and values.
Yep, just like a database. Imagine you have a question about a sentence. You use keys to search for the relevant info within that sentence, and then the values that are connected to those keys give you the answers.
So the model is like actively searching for connections and relationships in the data instead of just passively processing it in order.
That's a great way to put it, yeah. And that's where the scaled part comes in. The dot products between queries and keys are scaled down to prevent them from becoming too large. This ensures the model focuses on the most relevant connections.
I see.
And it helps with stability during training, too.
Okay, this is starting to make sense. But doesn't calculating all these relationships between words get computational expensive?
That's a really good question, and here's where the magic of the transformer really shines. Because it uses these attention mechanisms instead of sequential processing, it can handle these calculations in parallel.
Whoa, that's efficient.
Meaning it processes all the words in the sentence at the same time.
That's cool.
It's much faster and way more efficient than RNNs, especially for long sequences.
So it's like reading the entire sentence at a glance instead of going through it word by word, right?
Exactly. And this parallel processing was a game changer for training these large models.
It must have saved a ton of time and resources.
You bet. The authors trained their large model, the one that got that record BLEU score, in only 3.5 days using 8 NVIDIA P100 GPUs.
That's amazing.
Yeah. And, some previous top-performing models needed weeks of training.
Really?
Yeah. And they needed huge GPU clusters, way more than just 8.
Wow. That's a massive difference in efficiency. But this attention mechanism,
Yeah.
is it really enough to capture, like, all the subtleties of language? Because language is so complex and context dependent.
That is true. That's where multi-head attention comes in.
Multi-head attention. What's that?
It's like instead of just one spotlight shining on the input,
Okay.
we have multiple spotlights,
Okay.
each focused on different aspects of the sequence all at the same time.
Oh, I like that analogy.
Yeah.
Multiple spotlights.
Right.
So it's like a team of experts all analyzing the sentence from different angles.
Exactly.
So like one might be focusing on the grammar, another one on the meaning, and another on the overall feeling, the sentiment of the sentence.
Yeah, you got it. And by looking at it from all these different perspectives, this multifaceted approach,
Okay.
the transformer can capture these really intricate nuances and dependencies.
Wow, that's super impressive. Okay, but I have to ask, if the transformer is processing everything in parallel, how does it keep track of the word order?
That's a great question. Word order is super important for understanding the meaning.
Right, exactly.
The authors solved this with something called positional encodings.
Okay.
They basically add info about the position of each word to the input. It's kind of like giving each word a label that says, hey, I'm the third word in this sentence.
So even though it's processing everything at the same time, it still knows the order of the words.
Exactly.
So it's like giving the model a map of the sentence.
Yeah, that's a good analogy. And they use sine and cosine functions to create these positional encodings.
Sine and cosine functions. Wow, now we're getting into some serious math. Why those specific functions?
Well, it's quite clever, actually. These functions create a pattern
Okay.
that lets the model understand the relative positions between words, even if it hasn't seen those specific positions during training.
That's fascinating.
It's like giving the model this intuitive sense of distance and order within the sentence.
Wow, that's some really ingenious engineering.
Yeah.
It's amazing how they thought of all these details to make this attention-based model work so well.
Right.
And the results really speak for themselves. But hold on, I thought we were only talking about language translation.
Well,
What else can this model do?
that's what's so exciting, those impressive BLEU scores.
Yeah.
They're just the beginning.
Really?
The transformer's potential goes way beyond machine translation.
Wait, there's more. Tell me everything. What else can it do?
Well, for one, they also applied it to English constituency parsing.
English constituency parsing. Remind me what that is again.
Right, that's where you analyze the grammatical structure of a sentence.
Okay.
And even with limited training data,
Yeah.
the transformer did exceptionally well.
Really?
It shows just how adaptable it is to different linguistic tasks.
So it's not a one-trick pony.
Nope.
This is amazing.
And the authors had even bigger dreams, you know?
Like what?
They thought about using it for images, audio, even video. They really thought this shift from sequential processing to a more parallel attention-based approach
Okay.
could totally change the whole field of AI.
Okay, now that is thinking big.
Mm-hmm.
But before we get ahead of ourselves,
Yeah.
I want to hear more about those results they got with machine translation.
Sure.
Can you walk me through some of those specifics?
Absolutely. Let's dive into the numbers.
Yes. Let's get into the details.
So we were talking about that impressive BLU score of 28.4 on the English to German task.
Yeah, that was amazing.
What's even more remarkable is they got this with way less training time and resources.
Wait, seriously?
Mm-hmm.
So they not only beat the competition, they did it more efficiently.
Exactly.
That's incredible.
Their model was trained for just 3.5 days
Wow.
on just eight key 100 GPUs.
Okay.
Remember, some of the previous models needed weeks of training
Oh, yeah, I remember.
on massive GPU clusters.
So that's a huge difference in terms of time and cost.
Yeah. Right. It makes the transformer much more appealing, for real-world applications.
For sure, where efficiency really matters.
Absolutely. And it wasn't just about speed.
Mm-hmm.
The transformer also performed really well on the English to French translation task, achieving a BLEU score of 41.0, again, beating all the previous single models.
So it wasn't a fluke.
Right.
It consistently got those great results across different language pairs.
Exactly, really cementing the transformer as a breakthrough in machine translation.
Yeah, imagine the impact.
Right.
It must have had a huge impact on making information more accessible,
Absolutely.
breaking down those language barriers.
It's like they unlocked a whole new level of accuracy and fluency,
Right.
something that wasn't possible before.
Yeah. I bet this had a massive impact on the whole field of natural language processing.
Oh, absolutely. Researchers were super excited and started trying out the transformer architecture for all sorts of tasks. And they were getting really impressive results across the board. We mentioned earlier they used it for English constituency parsing.
Right. Analyzing the grammatical structure of a sentence.
Mm-hmm.
And how to do with that.
Amazingly well. Even with just a little bit of training data, The transformer was able to really grasp the grammatical intricacies of English sentences.
That's so cool. So it's not just about translating languages.
Right.
It's about understanding language itself on a much deeper level.
That's it. It's really just the beginning, though.
Real.
Remember those possibilities we talked about?
Yeah.
Applying it to images, audio, video?
Yeah, those are really exciting.
Well, those are starting to become reality.
Oh, okay. Tell me more about these applications beyond text. I want to hear it all.
Well, just imagine a world where AI can translate speech as it's happening in real time.
Yeah.
Or generate realistic images just from descriptions.
Right.
Or analyze complex medical scans with amazing accuracy.
That's mind-blowing. It sounds like transformers could revolutionize everything.
Yeah, I mean, from healthcare to entertainment to how we communicate.
Absolutely.
It could change everything.
It goes even deeper than that, you know? The transformer's ability to learn these long-range dependencies and understand complex relationships, it could lead us to a much deeper understanding of human language.
Wow.
Cognition.
Okay.
Even the world around us.
That's getting pretty philosophical.
Right.
It is really exciting to think about what this technology could do for how we understand ourselves in the universe.
Yeah.
But, I mean, with such a powerful technology, there have to be some limitations, right?
Of course, you're absolutely right. The transformer, as powerful as it isn't perfect.
Okay, so what are some of those limitations?
Well, one challenge is handling super long sequences.
Oh, okay.
While it's great at understanding connections between things that are far apart, there's a limit to how much information it can effectively handle at once. That makes sense.
Yeah.
So even with all its advancements, there's still room to grow.
Exactly. And another thing to think about is interpretability.
Interpretability, okay.
Even with those attention mechanisms giving us some insights,
Yeah.
it can be hard to really understand all the complex decisions happening inside.
So it's still a bit of a black box.
Kind of, yeah. And as with any new technology, we have to be careful about how it's used.
Right.
And the potential impact it could have on society.
Absolutely. It's not just about the technical stuff. It's about using it responsibly and ethically.
You got it.
Yeah.
On that note,
Yeah.
let's move on to the conclusion of the paper.
Okay.
The authors hint at some pretty exciting possibilities for the future.
Okay, I want to hear this. What did they envision for the future of the transformer?
Well, they talk about extending the transformer to handle different kinds of input, not just text.
Okay.
Like images and audio and even video, all within the same framework.
So one transformer model could handle all these different types of data. That's a game changer. It challenges how we usually think about AI needing separate models for different data types.
Right.
What kind of real-world applications could we see from something like that?
I mean, the possibilities are pretty mind-blowing. Imagine a transformer that could, analyze a medical image and then read a patient's records.
Yeah.
And even listen to the doctor's spoken notes and then put together a personalized treatment plan.
Wow. Or maybe a transformer could watch a movie,
Yeah.
understand the plot, and write a review.
Exactly. Or even create a sequel.
That's incredible. It's like we're talking about a universal AI that understands and interacts with the world just like we do.
Yeah, and the authors didn't stop there.
Oh, there's more.
They also thought about generating outputs in a less sequential way.
Okay.
Maybe even tackling some tasks in parallel.
What do you mean by that? I thought the transformer already processes things in parallel.
It does for the input, but the output is usually generated step by step.
Right.
What if we could break free from that and generate different parts of the output at the same time?
Oh, I see. That would be super efficient.
Right. Especially for tasks that involve creating big or complex outputs, like writing a book or composing music.
Yeah, that makes sense. Anything else? What about those local restricted attention mechanisms they mentioned?
Yes. So we've talked about how powerful attention is, right?
Yeah.
But sometimes it might be better to focus the attention only on specific parts of the input.
Cool.
Like imagine a transformer analyzing a long document. Instead of paying attention to every single word, it could just focus on the paragraphs or sentences that are most relevant.
Oh, that's a clever way to make it even more efficient. So it's like adding another layer of control to the attention mechanism.
Exactly. It helps the model be more targeted and could speed up training.
Wow. This is all really fascinating. It seems like the authors saw the transformer as just the beginning.
Yeah, like a foundation for even more amazing AI models in the future.
Absolutely. They weren't satisfied with just creating this groundbreaking model. They wanted to inspire a whole new way of thinking about AI.
And they definitely did that.
Right. The impact of the transformer is undeniable. It's pushed so many researchers and developers to explore new ideas and create applications we never thought possible. This deep dive has been an incredible journey. We've covered so much, from the basics of attention to all the amazing possibilities of the transformer.
It's been a real pleasure diving into this with you and our listeners.
As we wrap up, I have one final thought for everyone.
Okay.
The transformer is an incredibly powerful tool, but it's up to us, the humans behind it, to make sure it's used for good.
That's such an important point. It's not just about the technology itself.
Right. It's about using it ethically and responsibly to make the world a better place.
Absolutely.
So to all our listeners out there, we encourage you to keep learning and exploring the amazing world of AI.
Yeah, the future is in our hands, and it's an exciting time to be a part of it.
This has been The Deep Dive. Thanks for joining us, and we'll see you on our next adventure.